Hello again. This is Ms. Nakayama, and today's lesson is 6.2 Bisectors of Triangles. This is when we're getting into some more vocabulary, and this is so important for you to keep it straight. So I can't encourage you enough to think about the vocab as you work through these problems. Okay, so to get started, we have concurrent lines, rays, or segments. This is an example of concurrent lines. 3 or more lines that intersect at one point, and that one point would be called your point of concurrency. So we have concurrent, meaning an adjective describing lines, rays, or segments, and then the actual point of concurrency is where they all intersect. Then we have perpendicular bisectors of triangles. They're really the perpendicular bisectors, let's go ahead, of a triangle is any segment, line, or ray that is perpendicular to the side of a triangle at its midpoint. Okay, so clearly I've got these two tick marks letting you know that those two are congruent and the symbol showing that it's perpendicular. So a perpendicular bisector, pretty self-explanatory, is that which bisects the side, is perpendicular to the side at its midpoint. So I hope you can figure out that we could have one per side, and that would be 3 perpendicular bisectors, and they will have a point of concurrency. And their point of concurrency is called the circumcenter of a triangle. Now, here is a picture of an acute triangle. The circumcenter is inside the triangle. A right triangle where the circumcenter is on the triangle. And then we have an obtuse triangle where the circumcenter is outside. One thing to help you remember, the circumcenter, the reason it's called the circumcenter, y'all, is because it is the center of each of these circles, and each circle is circumscribed around the triangle. That means that every vertex of the triangle is on the circle. Okay, so it is the point of concurrency of the perpendicular bisectors. Next, we've already talked about this before, but you could have an angle bisector of a triangle. Okay, that would be any ray or segment that divides the angle into 2 congruent adjacent angles. And what is so important about that is that if you draw an angle bisector from each angle of a triangle, their point of concurrency is called the incenter. And why is it called the incenter? Is because it is the center of, and I'm not going to be able to draw this very well. I'll try it. Let's see if this will work for me. Okay. It would be the the center. Let's see if that works. It's not. That didn't do very well. Anyway, it would be the center of an inscribed circle. Okay. Now, one thing to keep in mind and to try to help you keep these things straight, okay, in your vocab. These are some little mnemonic devices that previous students came up with. So, PB, the circumcenter is the point of concurrency for the perpendicular bisectors. So we remember this as the perpendicular bisector, peanut butter crackers. If you think of peanut butter crackers or peanut butter cookies, if you always remember that, then you'll know that the perpendicular bisectors intersect at the circumcenter. And then the angle bisectors, I had a student come up with ABI, angle bisectors. That's like the Alabama Bureau of Investigation, FBI, ABI, and that's I is your incenter. So you've got to keep these two things straight. So just trying to give you something to help you do that. All right. Then we have 2 theorems. We have a circumcenter theorem, and we have a incenter theorem. Okay. And it tells you that if you know that P is the circumcenter, okay, if P is a circumcenter, that means that it connects these perpendicular bisectors. It's that point of concurrency. Then it is equidistant from the vertices. And the incenter theorem says, well, if these are the angle bisectors, then P is equidistant from the sides. So what you want to remember, and the really key part about it is, if the segments bisect the sides, then that point of concurrency is equidistant from the angles. If we're talking about bisecting the angles, then that point of concurrency is equidistant to the sides. So if it bisects the sides, it's equal to the angles. Bisects the angles, equal to the sides. Again, trying to help you remember this point right here, so you have to know what you're starting with. All right, let's look at the problems that we're going to have to do. So in exercises 1 through 3, find the indicated measure. Tell which theorem you used. Okay, so circumcenter theorem bisects the sides because, all right, it's the perpendicular bisectors for the PBC. Circumcenter bisects the sides. Incenter bisects the angles. All right, so in this first picture, we have something, PD, PH, PE. Those are all bisecting the sides. Sorry, don't know why it does that. All right, it's bisecting the sides, and if it's bisecting the sides, then I know it's the circumcenter theorem. And if it's the circumcenter, that means it bisects the sides, it's equidistant to the angles. So if I know that PC is, or I know that BP is 6, that's the distance to an angle, then I know this guy has to be 6 and that guy has to be 6. So I know that PC is equal to 6. All right, look at number 2. I have, I got to look at that picture, and I have perpendicular, and I'm told that each side has been bisected because of the tick mark. So again, perpendicular bisectors, PBC, circumcenter theorem, and that means it is equidistant to the angles. So in this case, that means that PB is 15. Since I know PB is 15, I know that PC is 15, and I know that AP is 15. So sometimes, to me, I think it helps if you draw it on the picture before you actually answer the question. You just kind of get used to looking at it and helping it register to your brain. All right, look at this one. I do not know the sides have been bisected, but I can look and see that each angle has been bisected. So if I have angle bisectors, ABI, that means this is my incenter theorem. And that means that if it bisects the angles, it's equidistant from the sides. So if PN is 11, then that means PM is 11, and that means that PL is 11, not 11. So to answer the question, MP is 11. All right, look at this number 4. Find the coordinates of the circumcenter of the following triangle. Circumcenter, okay? Again, what do I want to remember? I want to remember that, excuse me, circumcenter is peanut butter crackers. So it's where the perpendicular bisectors intersect. So I'm going to draw a perpendicular bisector. I love this computer. Perpendicular bisector of each side. Okay, y'all, when you have a triangle, the easiest sides to perpendicularly bisect are the ones that are horizontal and vertical. So if I go from 0 to 6, then I know halfway is going to be 3. So I'm right here. So this one is going to be, whoops, do my best to draw, well, and I missed it. But anyway, you got the idea. And then I'm going to go bisect the vertical segment. The vertical segment has 3 squares, so 1.5 of those squares is going to be perpendicular bisector. And so when I draw that perpendicular point, then I can see, and I got to be on the triangle, y'all. So even though my lines aren't exactly straight, you can tell where the point of intersection is. So, and again, you can go ahead and draw 3 of them, but we know that all 3 of them are going to intersect in the same place, so you actually only have to draw 2 of them. But if you want to be absolutely sure, go ahead and draw 3. So the coordinate of my perpendicular, my circumcenter, excuse me, is 3, 2.5. All right. Number 5, find the coordinates of the circumcenter. Again, circumcenter is where my perpendicular bisectors intersect. All right, so I'm going to go with, you've got the picture. I went ahead and graphed it. So graph it on your paper. It looks like this. And if I have to draw the perpendicular bisector, so I'm going to go between A and B. If A is -5 and B is +5, then I know that halfway between is right here. Okay, so now if I need to draw another one, I got to find the midpoint. And, you know, actually I didn't finish this, but y'all, the perpendicular bisector is coming straight down like this. It doesn't curve at the end, but my finger's having problems. Okay, so now I'm going to go find the midpoint of one of these sides. It does not matter which one, but I know that I'm going over 5 and up 5. So that means that I'm going to go over 2.5 and up 2.5 to get to that midpoint, which is going to be right here. Okay? And I've got to be an opposite slope. Okay? So it's easy with horizontal and vertical because you just have to switch it. But this slope right here is -1 on each of these, down 1 over 1. So that means this slope has to be +1. So I'm going to go down. I mean, you can do as many as you want. I can go down 2.5 and over 2.5. So I know that the perpendicular bisector, totally, it's really bad, but it's going through there. It's that line y equals, let me try it one more time. If I go through these, that's a little bit better. Okay, so where do these two intersect? Well, surely you can see it's at the origin. So it's 0, 0 is our circumcenter. All right, in figure number 6, in the figure shown, NE is 6x plus 1 and NF is 4x plus 5. Find ND. So I'm looking at the picture. I've got angle bisectors. If it's angle bisectors, that means it's bisects the angles, it's equidistant to the sides. So that I know each of these NF, I should write that. All right, so I know that I can do it on here. NF has to be equal to NE, has to be equal to ND. Those all have to be the same. They give me NE and NF in my directions. So I know that 6x plus 1 has to equal, not that, 6x plus 1 has to equal 4x plus 15. If I subtract 4x and subtract 1, 2x equals 14 and x equals 7. But I have to find ND, and ND is the same. You can plug it into either of them, y'all, okay, because they're all the same, ND, NE, NF, okay? I'm choosing the NE expression because that seems a little bit easier to calculate for me. So NE, which is the same as ND, is equal to 6 times whatever x was plus 7. Plus 1. So when I plug in 7, I'm going to find out that NE is 43. So that means ND is 43. All right. Number 7. We have a picture here, and we know some expressions. GL is 4x minus 2. GE is 3x plus 2. GK is 2x plus 8. We know that GC, GD, and GE are perpendicular. Okay, what you're missing on your sheet, so you need to add that to it because you don't ever want to assume anything, is that JC is congruent to CL, JD is congruent to DK, LE is congruent to EK. That means that these are GC, GD, and GE are your perpendicular bisectors because that is congruent to that. This is congruent to this, and this one's harder to move, but 1, 2, 3 is congruent to 1, 2, 3. So we know that we have the perpendicular bisectors, and if I have the perpendicular bisectors, that means that G is my point of concurrency of my perpendicular bisectors. It is the circumcenter, and if it bisects the sides, it's equidistant to the angles or each vertex. So I know that GL equals GK equals GJ. And they gave me GL and GK, so I'm going to have 4x minus 2 equals 2x plus 8. Subtract 2x and add 2. So 2x equals 10 and x equals 5. And so JG is going to be, where's J? Do I have JG? It's equal to either one of those. Which one did I choose? Whatever reason, I chose GL, but that's the same thing as GJ. So GJ is 4x minus 2 and x is equal to 5. So JG is going to be equal to 18. JE, they tell me, is 3x plus 2. So since JE is 3x plus 2, x again is 5, so JE has to be 17. All right, make sure you put that in your notes so you won't think you couldn't do this problem if you did not have that information. Okay? All right. Number 8, the perpendicular bisectors shown with the dashed lines, so they're telling me they're perpendicular bisectors, of triangle ABC meet at point G. So G is my circumcenter. Find the indicated measure or complete the statement. So again, I'm going to encourage you, y'all, draw on this picture, write it, because it's just so much easier to go back and fill in. We did just say G is the circumcenter, so you don't have to write that part on there. But I'm going to go back here and they tell me if all those sides are bisected, then I know that that has to be 15, that has to be 20, and that piece has to be 24. And if it bisects the sides, it's equidistant to the angles. And did they tell me anything? We don't know anything. Oh, we do. They see right here that GC is 25. So if GC is 25, then GB is 25 and AG is 25. So now I've got all those things marked. Now, they also told me I had perpendicular bisectors. So that means I know that these are all right angles. Okay? So, got to remember your Pythagorean theorem. So AG, now if I go back to the problem, number 9, AG, did I write that on my picture? Yep, that's 25. BD is on my picture as 20. CF, looking at my picture, CF is 24. AB, looking at my picture, that's 20 plus 20, so that's 40. CE is 15. DG, I do not have DG, okay? I don't have it. So what you got to remember is that this right here, because it's a perpendicular bisector, that makes a right triangle. So that means that DG, 20 squared plus x squared, for lack of a better, you can put DG if you want, is equal to 25 squared. So if you take 25 squared, 625 minus 400, you get 225, and the square root of 225 is 15. So DG is 15. The measure of angle ADG. ADG is a right angle, so we know it's 90 degrees. BG, where is BG? BG is 25, so 25 has to equal 2x minus 15. Add 15, and so x is going to equal 10, 20. Because 40 divided by 2 is not 10, it's 20. Okay, last problem. Point T is the in-center. Okay, so if T is the in-center, that means that it has to, so think about this, y'all. If it's the in-center, then this is a circle, and that means that each of these, W, T, TS, and TU are all radii. So they all have to be equal to 15, okay? And if it is, those are all the same. Let's see what we have. So ST we just figured out was 15. UR, okay, UR is right here, and that is a triangle, a right triangle. Golly jeepers. Is a right triangle. So I'm going to use Pythagorean theorem and say that 15 squared plus x squared equals 26 squared. So the square root of 26 squared minus 15 squared is not a whole number. It comes out to be 21.24. I would encourage you to put that in your calculator and make sure you can do that correctly. TU, we already said, was 15, so 15 equals 2x minus 1. Add 1, and x is going to equal to 8. So that is the end of bisectors of triangles. I hope that was not too difficult for you. Thank you so much for watching, and y'all have a great day.